The weirdest Soviet military projects ever attempted. Land-based weirdness. Vehicles that defied logic. Antonov, a 40 flying tank. Soviet engineers bolted an enormous biplane wing and tail assembly onto a T-60 light tank, creating a flying armored vehicle. The idea was brilliant in theory: tow it behind a bomber and release it on target. The A-40 actually flew briefly before the towing bomber nearly lost control from aerodynamic drag. The project was canceled after realizing flying tanks were too heavy, too slow, and impractical. The prototype never saw combat, but for one moment, the Soviets had attempted to make tanks fly. Amphibious lava truck. Soviet engineers designed an all-terrain amphibious vehicle that looked like a floating bathtub with guns. The lava could drive on land, swim through water, and climb obstacles. The problem was it did none of these things particularly well. It was too heavy for water, too slow on land, and too fragile for combat. Most were abandoned as logistics nightmares with spare parts that did not exist. Neoker smoke generator. This massive vehicle carried smoke generators designed to create artificial fog across entire battlefields. In 1945, Soviet engineers believed obscuring vision would revolutionize warfare. The truck could generate smoke clouds hundreds of meters wide. The problem was, smoke did not distinguish between friendly and enemy forces. Your own army could not see either. The project proved tactically useless and was abandoned. Kraz Avtohad self-propelled bridge. Soviet engineers designed a massive truck that could extend a bridge from its own chassis to cross rivers. The Avtohad would deploy hydraulic bridging equipment and create temporary bridges for other vehicles. It was mechanically brilliant and practically useless. Bridges took hours to deploy, supported limited weight, and enemy artillery would destroy them easily. The Avtohad never found practical military applications. Sherp ATV Beast. Soviet engineers designed an all-terrain vehicle with tires so large they could climb almost anything. The Sherp could cross swamps, rocky mountains, and deep water. It was mechanically extraordinary, but it was slow, fuel inefficient, and difficult to maintain. By the time it was perfected, cheaper helicopter transport had made it obsolete. The Sherp remains a curiosity, answering questions nobody asked. Avtomatический tankovik automatic tank. Soviet researchers attempted to create an unmanned autonomous tank that could navigate and engage targets without human control. In 1939, this was science fiction thinking. The system used crude mechanical guidance and acoustic targeting. It could barely navigate straight lines. Target identification was impossible. The project was abandoned when engineers realized autonomous vehicles required computer technology that would not exist for 40 years. Flying weirdness, improbable aircraft. Kalinin K-7 giant bomber. Soviet engineers designed a bomber with a wingspan rivaling a B-52 decades before it existed. The K-7 featured 7 engines and fuselage large enough to carry multiple tons of bombs. The problem was structural strength. Massive wings required enormous strut bracing, making it look like a flying construction project. It crashed in 1933 from structural failure. Engineers learned that bigger did not always mean better. Tupolev Zveno composite aircraft. Soviet designers created a parasite fighter system where fighters would launch from beneath a larger bomber. The Zveno actually worked. Multiple composite aircraft designs flew successfully and were tested operationally during World War II against the Chernovoda Bridge. Fighter pilots launched from the bomber, struck the target, and returned safely. But coordinating launches and recoveries proved difficult and impractical once conventional fighters became fast enough. Bartini Stahl, 6 stainless steel experimental. Italian-born Soviet engineer Roberto Bartini designed an aircraft constructed entirely of stainless steel. The Stahl 6 could fly faster than contemporary fighters, shattering speed records. But stainless steel was expensive, difficult to manufacture, and heavy. After proving the concept, engineers realized aluminum alloys achieved similar performance with far less complexity. Grigorovich Kite Launcher. Soviet engineers designed a fighter aircraft that could be towed behind a bomber on a cable and launched into combat by winch release. The system was theoretically sound, but practically a nightmare. Launching fighters under tow proved dangerous. Coordination between bomber and fighter was nearly impossible. Conventional takeoff methods soon made the hybrid system unnecessary. Tupolev Tu-95 LAM-powered experimental. To test nuclear-powered aircraft concepts, Soviet engineers installed a working nuclear reactor in the bomb bay of a Tu-95. The reactor actually ran during flight. The aircraft flew multiple missions with active nuclear propulsion. The only problem was every test flight exposed crews to radiation. Shielding proved inadequate, and crash risk was catastrophic. The project proved nuclear aircraft were mechanically feasible, but impractical. Myasishchev M50 Bounder supersonic bomber. Soviet engineers designed a massive delta-wing supersonic bomber intended to deliver nuclear weapons at Mach 2 across intercontinental distances. The M50 appeared at aviation shows, stunning Western observers. The aircraft suffered from engine limitations and fuel consumption problems, making intercontinental range impossible. Only one prototype flew. Western planners nonetheless believed Soviet supersonic bombers posed an existential threat. Spiral suborbital spaceplane. Soviet designers conceived of a spaceplane that would launch from a hypersonic carrier aircraft, reach orbital altitude, conduct reconnaissance or bombing missions, and return to Earth. The spiral represented the most ambitious merger of aviation and spaceflight. Only subscale atmospheric test beds flew. The full-scale aircraft never left the design phase, but demonstrated Soviet thinking about military space operations. Naval weirdness, bizarre warships, Typhoon-class submarine behemoth. Soviet engineers designed a submarine so enormous it was initially classified as a ship by American satellites. The Typhoon class displaced over 24,000 tons submerged, making it the largest submarine ever built. Inside, it carried 20 nuclear missiles. The problem was that something that large could not move quietly. Enemy sonar detected Typhoons constantly. Maintenance required ports large enough to accommodate these massive vessels. Ekranoplan ground effect vehicle. Soviet engineers discovered that flying a few feet above water surface generated enormous lift through ground effect physics. They built massive vehicles that could carry weapons and troops at high speed just above the water. The Ekranoplan was neither ship nor aircraft. It could cross oceans at speeds approaching 300 miles per hour. American satellites initially classified it as a ship. Operational effectiveness was limited, and the program was abandoned. Moskva-class helicopter carrier. Soviet engineers designed a warship that was primarily a helicopter transport with a few guns attached. The Moskva class could carry more helicopters than many naval air forces operated. Vertically, it was an engineering marvel. Horizontally, it was a naval vulnerability. These ships were slow, required constant protection, and proved too expensive to operate in peacetime. Tarantul-class fast attack craft swarm concept. Soviet naval designers believed that swarms of small fast attack craft armed with missiles could overwhelm large warships. The Tarantul class proved this concept by building dozens of extremely fast, lightly armored vessels. The problem was coordinating swarms of independent vessels proved difficult. Losses in combat would quickly reduce swarm effectiveness. Modern weapon systems made the entire concept vulnerable. Weapons and defense weirdness. Strange arms. Perimeter doomsday machine. Soviet engineers designed an automated nuclear launch system that would trigger massive Soviet retaliation if command authority was destroyed. The perimeter system could detect nuclear detonations in Soviet cities and automatically launch strategic nuclear weapons against the United States without human authorization. It was designed to ensure retaliation, even if the entire Soviet leadership was killed. The system remained partially active even after the Soviet collapse. Almaz orbital weapons platform. Soviet planners designed armed space stations that could attack targets on Earth or in space. The Almaz featured cannons, missiles, and orbital maneuvering systems. It was the first militarized space station. The concept proved that weapons could operate in orbit. Practically, space weapons proved unreliable, difficult to maintain, and vulnerable to counterattack. Zvezny Gorod flying combat platform. Soviet engineers designed a massive aircraft that functioned as a flying weapons platform capable of loitering over battlefields for hours. It was essentially a gunship scaled to absurd proportions. The aircraft could carry enormous ammunition loads and powerful cannons. The problem was that anything that large could be detected easily and destroyed by enemy fighters. ROKS acoustic mine. Soviet military engineers designed underwater mines activated by acoustic signals from friendly submarines. The mines would lie dormant until receiving coded acoustic signals. The concept was brilliant. Friendly forces could navigate through minefields by transmitting deactivation codes. The problem was that enemy forces could eventually decode the signals, disarming or triggering mines prematurely. Impulse wave generation weapon. Soviet researchers attempted to create weapons using electromagnetic pulse technology. Early ideas involved generating massive electromagnetic bursts that could disable enemy electronics over wide areas. The concept proved that electromagnetic weapons were possible. Practically, early systems were too large, too unreliable, and consumed too much power. Space and high-altitude projects, reaching beyond atmosphere. Energia, super heavy launch vehicle. Soviet engineers designed a launch vehicle so powerful it could carry 100-ton payloads to orbit. The Energia represented the most ambitious Soviet space project. It could launch military space stations, orbital weapons platforms, and massive scientific instruments. The Energia flew successfully several times, but then the Soviet Union collapsed. A handful of missions proved the concept worked. Buran spaceplane. Matching the American space shuttle capability for capability, Soviet engineers designed the Buran spaceplane to launch on top of the Energia rocket. The Buran could carry large military payloads to orbit and return them to Earth. It flew once successfully, and then the Soviet Union collapsed. The Buran matched space shuttle capability in every measurable way, but required resources the collapsing Soviet Union could not provide. ROKS anti-satellite cannon. Soviet researchers developed an orbital anti-satellite system that could destroy enemy satellites by firing projectiles in orbit. The ROKS used kinetic force rather than explosives to destroy targets. The system was tested successfully multiple times. It proved that satellite warfare was feasible. Each successful test created space debris that threatened other satellites.